This is probably the biggest and most disruptive set of changes to Java since its inception. So be prepared. So a little bit about me. One of my books is out there. I'm co-author on the EJB3 in Action 2nd edition, and also co-authored the NetBeans certification guide. So of course I'll be focusing a little bit on NetBeans as I go through the presentation. So I'm slightly biased there. I'll have the contact information as well as a link for the slides up at the end of the presentation. The slides will go up online later this afternoon. Afterwards. So Project Jigsaw, at its heart, the goal is to make there's several goals for Project Jigsaw. The two main driving points are to provide reliable configuration and strong encapsulation, both of which are somewhat lacking from the platform currently. So the goal is to make the Java platform more scalable for small computing devices, and we'll see how that's accomplished via Jigsaw, especially via the new module layouts and JLink. Improve platform security and maintainability. As a part of this change, they've radically refactored the Java runtime itself. So we'll see some slides where I go over how the runtime is actually changed. And also, as a part of that, in fixing stuff and cleaning up things and removing the rat nest from the platform, it will improve security so that we will no longer have many of those security exploits that we've had in the past that have troubled the platform over the last couple of years. Also enable improved application performance and simplify library creation and development. And I want to focus, specifically on reliable configuration. I mean, how many times have you started up an application to get the, class not found exception? One of the things with Project Jigsaw is that should no longer happen going forward in the future. When the application starts up, it'll actually build up a graph of all the dependencies and ensure all the dependencies are actually met. So why modules? Well, Java currently suffers from jar hell. I've seen production environments where there's over 400 jar files in production, whereas separate services groups have customized the application and added in dependencies. And in some cases, nobody's actually gone through to make sure that some of the dependencies aren't conflicting, right? It's just, depending upon how the class path gets set up, the correct dependency ends up ahead of the incorrect dependency in the list. So I think many applications are that way. I've seen systems that, working for previous companies where I had to go into different companies where they had, people just kept dumping jars onto the class path until the application started or worked, right? There were duplicate copies of the same jar file. I mean, I was kind of, I've seen some very interesting runtime deployments with that, along with errors that nobody seemed to be noticing at the time. One of the things is Maven does track dependencies. Maven Gradle does track dependencies, but it doesn't enforce them at runtime. So although you can have your dependencies correctly set up and be tracking them using your build tools at runtime, people can do all sorts of weird things through all sorts of weird jars on the class path, etc. I've seen where somebody's to add a customization took and dumped the entire class path of WebLogic into Glassfish, and then calls up saying, "Well, we're getting these really bizarre errors." So hopefully going forward, we'll have the guarantee that an application can no longer start up because you won't get a class def not found, or some type of weird behavior where it looks like you're running with two different versions of the same library where it's found different pieces of it. So that kind of goes into the next point where it's possible to mix library versions on the class path, where somebody, you add in Commons IO 2.5 and then 1.6 is also on the class path. Which one does the application actually, run with? I mean, have you ever gotten an error message where, the method is no longer, it can't find the method, right? It compiled fine, but then at runtime it can't find the method. And then one of the things that comes up, and I'll have a slide on the comparison between OSGI and Jigsaw, there are, like OSGI has been around for, practically 20 years at this point, but OSGI can't be used to modularize the platform. And there's a fundamental difference between OSGI and the Java module system that as has been implemented. So I will kind of go into that a little bit and explain the differences between the two of them. Project Jigsaw is made up of many different pieces. So the JSR is the thing that goes through the JCP. That's 376, the module system, which you can download the documentation. And then there are the Java enhancements, the JEPs. So the first one is Modular JDK, which is actually taking and applying JSR 376 to the JDK itself, actually modularizing the Java runtime, and also modularizing the source code layout of the runtime, which is 201. With 220, we get modular runtime images, and that, combined with the JLink, allows us to actually produce JVMs that just include the dependencies that we need to run. So right now, if you download, at least on the Mac, the full JDK installation is 450 megs, right? You can actually now just bundle up your application with the dependencies that your application uses and the things that the runtime needs, and you can get it down, I think, as low as like 30 megs, and you get a 30 meg image that you can then hand off to somebody to install your application. So now, if you're trying to run it on, in a smaller Raspberry Pi, you don't have to download the entire JDK, the entire Java runtime for it. Of course, the JDK is large because it includes additional tools, but it's much smaller. You can produce much smaller images now. Also, they've encapsulated most of the internal APIs, so this is going to have a pretty big impact upon, depending upon how your application was using the APIs, may have a big impact upon you than the actual module system itself. Okay. So the great news is that when I initially proposed this presentation, the original release date was July 27th. As you can see from the voting, it was voted down by the JCP, and the new target date is September 21st. So you still have time to download and evaluate the impact upon your application. And so now is definitely, if you haven't taken a look at it right now, I would definitely, after this presentation, start doing that. I don't know with some of the issues that have been raised with it whether they'll meet the deadline for September 21st. As one of the presenters said yesterday, this was originally targeted for Java 7 back in like 2010 or something like that. So who knows? Hopefully it'll make it in there. So you still have time, so definitely check out stuff. So in terms of the comparison, I actually pulled this from one of the write-ups. The link is at the bottom, where they highlighted where the people that voted no on the Project Jigsaw for Java 9 listed their concerns, and they had a nice table basically highlighting the differences between OSGI, Java EE, and Project Jigsaw. So as you can kind of see some of the differences between them. So for example, as we'll see in the presentation, you can't have cycles between modules, isolated package, don't have lazy loading. There is pretty strong restrictions on the name of packages. You can't have multiple versions of an artifact by default. There are ways of doing that with layers, which I won't get into in this presentation. It'll be a completely separate presentation. You can't have split packages across modules. There's all technical reasons for this, for the reason why they're doing that. Some of these I don't think that, I agree with. I don't think that we want versioning built into the base level system, that there's still a need. Java Project Jigsaw doesn't obviate the need, doesn't, make OSGI irrelevant. It's just is solving a different problem and actually modularizing the Java runtime. So it's kind of at a different level. But if you read the, you want a pretty good summary of, what are the concerns with it. The link at the bottom has information, has a pretty good write-up on that. Now, one of the other key differences of understanding Project Jigsaw and how it fits, stacks up against something like OSGI. OSGI uses basically class loaders to do its implementation of modules, whereas Project Jigsaw, this is actually done at the JVM level, and there's actually a separate layer right in there. They did not implement it using class loaders. So it's actually at a separate layer that's actually doing the enforcement. So that's what distinguishes Project Jigsaw from the other modularization systems on the Java platform. They did not change the class loader hierarchy in terms of how those existed. They did move many of the Java libraries out of the Bootstrap loader into the platform loader. And there's documentation and other presentations explaining that in more detail online. I'll have links to them at the end of the presentation if you're more interested in that. So some common questions to start off with Project Jigsaw is, do you have to modularize your application to run on Java 9, right? And the answer is no. You can run your application, hopefully run your application as it presently stands on Java 9. Java 6, 7, or 8 application compile on Java 9? This depends. So for many of you, as long as you're not drilling into the JRE like I've done in the past, yes, it should still compile as long as you're not using internal APIs or have hacked around internals of Swing like I have done. Will my Java 6, 7, or 8 application run unmodified on Java 9? Well, then again, that one also depends. So your application may compile, but then it may not run. It may run into problems running. So it depends. It depends upon your use of private APIs, and if you're doing something like reflecting into the JVM, like there's a couple of cases where I had to, and I work on a desktop. Part of our application is a Swing application that's 15 years old. So we get around some limitations in Swing. I actually reflect in on some of the Swing classes and set the accessibility so I can drill into stuff that I'm not supposed to, because I need to change things. So in that case, the application that part of the application will compile, but it will definitely not run. So you have to keep in mind that. How do you identify problems today? Well, since Java 8, they've included a JDepends library, application, command line application that you can run and analyze your jars and the jars that you depend upon to find out whether you have any, what type of issues you may run into with Java 9. So that's been out there for several years right now. So if you don't download Java 9, definitely try running JDepends to find out where you stand. Do any of your are you going to run into any dependencies? Because you might have done everything right, but one of your dependencies may not be available or may not work on Java 9. Can I partially leverage modules? Yes, and I'll get into that later in the presentation. Is the tooling ready? Absolutely not. Strangely enough, I mean, the Gradle 3.4, which I had installed for a long time on my laptop, actually would not start up on Java 9. It would actually error out. And there's parameters I think that I could have gotten it to work. You go out there and you Google, what's the status of Java 9, or what's the Gradle plans for Jigsaw. You're going to find an issue that somebody filed a year ago with comments on it. So the information is a little bit hard to find right now. Many of the Maven plugins don't work yet with Project Jigsaw or running on 9. And I can say that this is the first time since I was in college back in 2000 that I've had to use the Java C from the command line and write shell scripts to do the compilation. I started out using Ant back in 2001, then Maven and Gradle and so forth. So it was quite disorienting to have to go back and actually invoke the Java C command line for examples and playing around with the module system, because I'd forgotten that you have to pass in all of your source code files to Java C, right? I forgot that you had to do all those wonderful things back then. So I've been a little bit spoiled. So the tooling is definitely not there. IntelliJ added support, and I'll show that in the presentation. Back in March, they released 2017.1, which had support for Java 9 modules, and the NetBeans developer releases, not the current NetBeans release, but the developer releases. If you go in and drill, you can get the module support, and I'll demo those as well. Do the application containers work on Java 9 today? Maybe. I was able to start up Tomcat fine, and it appeared to come up and run. Glassfish 5 wouldn't even start, so that dies on startup. I haven't tried WebLogic or WebSphere to see how those would react. Now, it doesn't mean generally you wouldn't run the current release of containers on Java 9 because they haven't been tested with it. It's just I was curious for this presentation. I mean, obviously Java EE 8 is going to run on Java 8 because Java 9 isn't out yet. But I'm always trying something bleeding edge, but it doesn't run on 9. Can I try out Java 9 today? The answer is yes. You can download the release builds from OpenJDK and start trying it out, and that's definitely encouraging. So as I mentioned, JEP 200, this graphic is a little hard to read, but they modularized the JDK. So these are all of the modules of the JDK. So that's where a lot of time effort has been spent. I kind of zoom in on the section of it, and here you can kind of see the lines are the dependencies between the different modules. And generally, you're going to be by default to like right now how when you don't have to import Java Lang. You will not have to add as a dependency Java base that's automatically added as a dependency for your applications. Your application gets compiled against, I believe, Java SEEE when you do the compilation. But you can include, depending upon what you're doing. So if you're going to use, like, say, Nashorn, you then would have to add a dependency on Java scripting. Now the IDEs, like IntelliJ, if you go to import something in your Java class file that you've not imported a module for, it'll prompt you to add, that module to your modules file, and will automatically do it for you, right, as soon as you start using the code. NetBeans, you actually have to go back and look at the Java doc documentation to figure out which module you need to import. So it's also been a long time since I've had to really read the Java doc or use that to find, what I'm supposed to import. As I mentioned, the JDepends utility will also, list out the dependencies of a jar file, like what modules it depends upon or what modules your code depends upon. So it's a static dependency checker. The key parameters to it, you have this JDK internals flag, which will, flag the internal APIs that will break in Java 9. It also has this nice output directory where it'll output a series of files and a summarization, telling you what your dependencies are and what issues you'll run into. And you should run, as I mentioned, and I'll stress this again later in the presentation, run this on all of your generated output, and also on any of the dependencies, intransitive dependencies of your application. So you'd really want to drill down. And there is I'll have it later in the presentation, there's a Maven plugin that you can run and add this to your build today, so you can ensure that, over the next year, as you're going through, somebody doesn't add something and you don't end up with a dependency that's going to cause you trouble in Java 9. So this is an example here of running it with the JDK internals, and you can see that there are a ton of, for this one particular library, this is a widely used Swing component library. So if you have like a old Swing application that's still kicking around, a common library that you might be using, and you can see that there are a number of issues with this version of it. I don't know if newer versions have fixed this, but this will definitely be causing the project that I'm working on some trouble. But many of the libraries like this, you'll be somewhat surprised, because some of the things some libraries that I thought would definitely have problems had zero problems, and other ones I didn't expect to have problems actually had a lot of problems. So depending upon what you're doing, you should definitely take a look at that. And this is the output that you'll get. So this will give you an idea of what issues you have to run, and it can actually drill down and give you basically specific classes. Now Oracle has provided a nice little summarization sheet for many of the common problems that may identify, what the solutions are and what the problems and the solutions are. So if you're using that ComSun, base 64 encoder, there's now one in Java 8 that you should be using instead. So that's a pretty easy fix. So there's the link up at the bottom here for that web page, which has a list of, common problems and the proposed, what you can do to remedy the situation. And then this is the JDepends plugin for Maven, which you can also use from Gradle. So you should add this to your build process today if you're using either of those build systems, just to try to keep track of, what issues are you going to run, what issues are you potentially going to run into with Java 9, and to also ensure that nobody adds anything in the meantime that's going to cause you problems. So I'd definitely start tracking this today to be prepared. So that's kind of the basic introduction. So now I'm going to move on to module basics. So this is a simple meeting service. So in this case right here we have a meeting service interface that we want to expose, and then a meeting service implementation, and we want to hide that. Currently with the current Java 8 and before, how would you hide the implementation class, right? Because invariably somebody is going to drill in there and cast it to the meeting impl to actually get a hold of it, right? Or accidentally include that and use it directly. How do you, currently today there is no way to, unless you're using something like OSGI, to enforce that somebody doesn't drill into an API in unexpected ways, right? So that's a current limitation in Java as it is today, and that's one of the things that Project Jigsaw is addressing. So, pre-Java Java 9, we had public protected, package protected, and private, right? So there was no way, everything that was public in a package was public to everybody, right? So a public class was public, in a package. There was no way to say, I don't want, this package right here is public to my, library that I'm writing, but I don't want anybody else to drill into it, right? And if you've been following some of the problems that they've had with JUnit, like JUnit 5 is a complete rewrite, an incompatible rewrite of JUnit 4. And the reason why they've broken it like that is because every tool and everybody has drilled into JUnit and used APIs in JUnit that they were not intended to. So they can't actually make any serious, significant changes to JDK 4 without breaking tools and libraries that depend upon it. So with Java 9, we now have the ability to limit basically, what is exported from, you can kind of think of it, what packages are exported, what packages can other pieces of software access. So you can actually, not every public class is available to everybody in the JVM. Right, so we now have the ability to specify public modules and only, public within a module. So gives us that capability. So with some of the presentations yesterday, you may have already seen there's this new module info.java file that they've added, which defines a module and defines what you're exporting and what you require. And the reason why they've chosen module-info as a name is because, first of all, that gets compiled to a class file and you can reflect upon it so you can get the list of modules, etc. But the reason why they've done module-info.java is because it's not a valid class name and it is ignored pre-Java 9. So you can actually compile your code and target Java 8, and the Java 8 runtime will ignore the fact that this invalid class is there on the class path. So you can have code that runs on both 8 and 9. So if you're writing a library on Java 9, and that's a module, you can include a module info.java and it will still work on Java 8 or before. The contents define the following. So you define the unique name of the module, the dependency of the module, and the packages to be exported or used for other modules. And it's placed at the root of the namespace. And you can't export anything in the root either. So this is just a simple example that I'll drill into a little bit further as I move along. The syntax, now I put this together, so hopefully I'm not missing anything in this slide, but I put together all the possibilities, right? All the possibilities of things that you can put into this file, and we'll go over each one of these, but this is just a snapshot to give you the total number of things that you can put into this file. So we've got, the export, and you'll see, we're exporting a package, and you can actually give specifically another package access to it. Requires, I'll get into what the transitive means. We can open the module up and say it's, all of its content is available. The provides, that is the Java SPI, the service provider interface, so I'll get into that. That provides and uses are both part of that service provider interface rework that they've done with Java 9, with Project Jigsaw. So I'll get into that a little bit further along. So, module basics. The module names must be unique. The names should follow, or that seems to be the current convention that everybody's doing, is the names should follow the reverse domain name pattern because they have to be unique for all the modules, right? Modules are eagerly loaded, so the dependency graph is built and checked on startup of the application, so if any modules are missing, it won't start. Or if it detects a cycle, anything when the JVM starts up, it goes through all the modules. If any problems are detected, the application does not run. There is currently no support for versioning, although that was one of the issues that was raised up in the voting. Only one version of a module may be loaded, although you can use layers, if you're like writing an application container for that. So, and I'll get into on the next slide about versioning. So, two modules with the same package names in them are considered to be different versions of the same module. Two modules with the same name are considered to be two versions of the same module, so keep those two in mind. And then concealed package conflicts. So when two modules have the same package name in them, but the packages are private in both modules, module systems cannot load both modules into the same layer. So this is one of the hidden changes. So if you have an application where you've got, my company utilities in one jar file that you build up, and you're going to turn that into a module. And then elsewhere in your application, you have my company utilities in another jar file. That's going to cause you trouble And so that's going to require some refactoring or changes on your part. If you port that over and run with the module system, that will cause problems. One of the new things, so in the past we had the class path. With Java 9, the module path has now been introduced. So you have module path arguments that are now included with all the command line utilities. So you've got this module path, upgrade module path. So we've got a variety of different ones that are now on Java C and the Java command. You can also use Java list modules to list all the modules on the system or within a library. So JDK modules, so JDK base is the one that's is included by default. So you don't, when you fill out your module descriptor for the code that you're writing, you don't have to include JDK base. That's automatically included for you. The Java SEEE contains the following modules. So these are usually provided by application containers. So these are not available by default when you're running your application. I'll get into a case with this later in the presentation explaining how the ramifications of this. And as I mentioned, you cannot have dependency cycles with your modules. So here I have, my model depends upon utility and utility depends upon module. If I did something like that, the application will not start up and will not compile actually either. So if you have code like that, and in this case right here, I've got another cycle where model depends upon admin, admin depends upon util, and util depends upon model. This type of situation would also cause a problem. And depending upon how complex or how spaghetti your code is, it might take a while for you to iron out these changes if you're moving your application over to running with modules. Now remember, if you don't use the module system in Java 9, and you have jars with like this type of dependency graph, you can still run your application. You don't have to refactor your application just to get it to run on 9. However, if you modularize your application, you would have to address code problems like this. So moving on to a simple module example. So in this case here, as you can see, I've put the command line down below for compiling it out. I have my meeting service, and I have the impl, and the impl is hidden, so I only export the interface, right? So that's the only thing that other modules could actually instantiate or see as the meeting service. Nobody else can drill into the meeting service impl. They can't use reflection to get at it. They can't try to cast it. There's no way that they can actually get a hold of that impl, right, and try to work with it directly. And then when you compile it out, you end up with, basically as you'd expect, compile it out and into the jar file, and also this module, the module info gets turned into a class file. It's module definition. So a more complex example, so that's just looking at, creating one module, is multiple modules. So in this case right here, I have my model and then my services, and services depends upon model. And I've got, so the model exports the model package, which contains meeting and speaker. And then the actual service requires the model. So this is where I'm setting up my dependency to the model, and exports the services outside of that. And there's actually a problem with this, which we'll get into, of a consumer of meeting service in a subsequent slide. So just keep that in mind. So this is defining multiple modules and the dependencies between them. Now, with Java C, now not all the tools will currently support this layout, but Java C now has this module source path, and you provide the source directory containing your modules. And then within that source directory, you've got directories for each one of the modules, and the name of the directory is the module name. And so what Java C will do is it will generate output, basically an output directory with directories for each one of the modules with the source code in them that you can then pass to the jar thing and generate the jar files for it. But in this case right here, on the previous example, we had our model and our service modules. You can see that we've got two directories with the name of the module, and that has to map up with what's in the module files themselves when you're compiling this way using the thing. Now you can compile them separately, and that's what I believe the tools are doing right now. So they're not actually using the module source path. They're compiling each module individually and putting it into a jar file. But if you're using the Java C command line, you'd have to set up your project this way in order to use a module path. Otherwise, you'll get kind of a very confusing error message if you fail to do that. And then for packaging, this is generating the jar file, and you can provide a version of the module. There's this -- module version. So it's recorded in the module info class, but it isn't actually used anywhere. So that's not actually module versioning. It doesn't actually support. It doesn't actually do anything with it. So transitive dependencies. Earlier I mentioned that there was a slight problem with my services. Now I add a third module called the admin module, which uses the services to actually schedule meetings. So there's a depends on relationship between the admin and the services module, and then the service module depends upon model. And there's this transitive relationships between the admin and the model, because on the services interface, I actually take a meeting object which comes from the model, right? So that actually has to be taken into account when I'm defining my modules, that people that use the services are going to need access to this dependency in order just to even use it, right? That's a transitive dependency. So how is that actually encoded in the module file? So in my services module, I would have to add transitive. When I say that I require model module, I have to add transitive to it to say that, basically export this out so that the people that are using this module can then, get access to the meeting objects, because otherwise the interface is completely useless to them. Right. So you have to take that into account. That I have these set of requirements, and then you can determine which of the dependencies of your modules you want somebody else to be able to see. Right. So I've seen it where somebody adds a jar file to the class path that came in with like a reporting engine, and then somebody else is doing code completion, and they accidentally use a class from a third-party package of another package that we've included, right, without realizing that they've done that. So now going forward, you won't have to, you'll be, yes, this requires work, but you can also guarantee that if you have like a large project with a lot of dependencies, that you're not accidentally including dependencies in from another library. Somebody does autocomplete. For example, years ago we had somebody wrote some code that I think used something from the com.apple look and feel classes accidentally. There was like a utility. There was a class in there that was also in one of like Commons Util or something like that. And they accidentally included the Apple one. And because the build system was running on a Mac at the time, it went out fine. It ran on a Windows box, suddenly it couldn't find com.apple. Now, of course, you went back and say, well, yeah, I can see it was the auto, somebody did auto-complete, did the auto, hit Alt-Enter in the IDE. It included that. They didn't look to see that it included the wrong thing from com.apple. So going forward, that won't be a problem, because now you can, when you depend upon something else, that other thing can say, well, I only export these, so you can guard against accidental things like that, which can introduce all kinds of problems into code. I can't, code reviews where somebody asked me, well, why did you import this? Well, wait a minute, I didn't actually look to see what the IDE where it imported it from. So you won't have to worry about that. So the next iteration of this, we're talking about what are called qualified exports. So my admin utility decided to write a JavaFX UI for it, so I add a dependency in there for JavaFX on the controls. Now I go to run that, and whoops, it blows up with a target invocation exception, a legal access exception. What exactly happened here? Well, JavaFX actually uses reflection on my module to instantiate my class, right? So it doesn't have permissions to do that, right? Because it doesn't import, it doesn't know anything about my module. So in order to do that, I have to add what's called a qualified export. So I have to tell the system that yes, you can export you can export my admin app to JavaFX graphics. You can give it basic permissions to be able to instantiate my, to use reflection on my code to instantiate something. And then also, so that's with the controls. And actually, in this case right here, what I'm pointing out, and the reason why these are in red is because graphics has the class that the graphics module has the package that does that does the reflection. However, I required the controls, right? So when I looked at that stack trace in the previous example, in the previous slide, I could see that it was a class from the graphics that was actually causing the problem, even though I only used controls. And the reason why that's the case is because controls depends upon graphics. Graphics is the one that did the reflection, so I have to give graphics the permissions to actually, the graphics module the permission to actually do the reflection. So as you can see, depending upon the complexity, so if you have something where you're depending upon something that has a hierarchy of modules, and that one of those modules does reflection onto something on your class, you're going to have to deal with that out of qualified exports. Now, in the end, with this application, I decided that I want to generate basically a standalone application that can be installed. So I can use the JLink to generate basically a JRE with just my application and the modules that are required. So the JLink, you pass in the module path and the output directory, and it generates basically what looks like a JRE with my modules and the modules from the JDK that are required to run my application, along with a script to actually run it, right? And you can generate these for different platforms as well. So, you know, the full JDK is 454 megabytes. With JavaFX added into this example, it is only 95 megabytes. And I think if I didn't include JavaFX, it would be something like 30 megabytes, right? So now you have something that's very small that you can include, that you can deploy your application. You don't have to include everything, which is kind of handy if you're doing like some of the stuff up in the cloud where you don't want to have to, you know, like Amazon Lambda, which I've talked about in the past. You wouldn't have to include everything, or, you know, some type of like runtime environment like that. You wouldn't have to upload the entire JRE. You could only upload the parts of the JRE that you actually need. So moving on, digging deeper into modules. The first one is this is some Java 8 code that basically, I think this was added in Java 7 or 6, where you can have basically a standalone web service in your application, right? You can write web services and you can export them from like a Java desktop application or a Java SE application, right? So in this case right here, I have a defined a SOAP-based web service, and then I publish it, you know, locally, so on the local machine. So something like, you know, this would be used in a situation where you want to have like Excel can actually make web service calls, so you can actually have a Java process running locally that's publishing web services, not running on a full application container, but exposing web services. So this compiles and runs perfectly fine on Java 8. This will compile perfectly fine on Java 9. However, when you go to run it, you'll get an error that you can't find this endpoint. You know, so what happened? This code ran on 8, compiled on 8, compiled on 9, but now you go to run it on 9 and it doesn't actually work, right? So this is an example of code that hasn't been modularized, right? It's just a jar file containing that code. You know, what happened? Well, you actually have to, as I mentioned before, it compiles against when I showed that module graph for the JDK, it runs with Java SE, not Java SE, which includes the web services packages. So you actually have to you actually have to add the module. You know, some of these, like if you had like a Java command line utility that used the activation framework, you're going to have, because that's part of the Java SE module, which is not included by default, you're going to actually have to add that when you run your existing Java code. So even if that was compiled on Java 8, you still have to do that on Java 9. You have to specify for those set of modules that I had on that earlier slide that you need to add those dependencies in. So that's the add module right there. Now, so far I haven't talked about module types. There's actually 3 different module types. They're what are called automatic modules. This is the mechanism for using jars which do not include any module info configuration information with it. So say your application, because it's going to take a while for, you know, third-party libraries to add in module support, right? So you want to use a jar file which doesn't have any module information in it yet. With a modularized application, you know, what happens? Does that jar file have to have a module? The answer is no. What the Java runtime will do is it'll create an automatic module on the fly. And so the module name becomes the name of the jar file minus any version information after it. So the module name is dynamically generated. It exports everything, all the packages. An automatic module exports all of its packages as public, right? So there's nothing that's private or hidden about it. So everything is public. It can read every other module. So that is how you can work with jar. You can add a jar file to the module class path and creates it as an automatic module for you. Right, so you don't have to go in there and add a module info into somebody else's jar file. Unnamed module, and there's actually a specific name for this. These are all jars and classes on the class path. So you could actually invoke the Java runtime and pass in, a class path and also a module class path. So they don't possess a name. There's actually all unnamed, I think, I have it on a slide coming up. And so these are contained. So actually what happens when you start up an application and you're not running it within the module system, right? So you don't have any module infos in your class path, it actually starts everything up and creates an unnamed module, and that's how it runs your existing application. So if you took an application from Java 8 and ran it on Java 9 with no module infos anywhere, it actually creates an unnamed module and runs your application using that. So modular jar, so if you pass it in, if you take a modular jar, that's one with the module info class in it. Run on the module class path, it runs as an application module. If you if you take that same jar file and pass it in on the class path, it gets instantiated it gets added into the unnamed module. And then for non-modular jar file one lacking the module info class, creates an automatic module if that jar file is on the module class path. If it's on the class path, it creates an unnamed module. And these are the read rules for who can actually read, so a named application. So it gives you basically, what are exported, who can read it. So there's all of these, there are read rules in terms of who can access what. So for example, you include by default, you have an automatic module that tries to do reflect. So that unnamed module, that automatic module tries to do reflection on some of your code. You're going to actually have to give it permissions and possibly pass that in on the command line to give it permissions to do reflection on your code, because all the rules still apply. Everything is public, but it doesn't have any, requires or anything like that. So this is kind of building out what I just mentioned. So in this case right here, I have an invocation library, and this is an automatic module with no module info, and it's doing reflection back on a class in the admin. So this is a class. This is the code for the instantiate utility. Basically, it takes a class name and instantiates it and returns it. And then over in my the admin module, I instantiate this utility and tell it to instantiate a class that's in this module, for which obviously it won't have permissions for by default. So this is the initial module definition, and you can see my invocation library is actually, because I'm starting it up on the module path, right? So I've looked at that and I've applied the rules, so I figured out what the name was. So it's myinvocation.jar, so the name of the module is going to be myinvocation library.jar is the name of the jar file. The name of the module that's going to be created automatically when the Java runtime reads it in is going to be my invocation library, right? So if I try to run this as it is right now, I'll get an illegal access exception. Now, so the question is, how do I give my library access to be able to instantiate code, because there's no module.info, there's no dependency between it. So in order to do that, oops, it's behind. Well, it didn't. Okay, there's actually an export opens, so that'll be up in the final slides. But I add an extra thing up there to export it and show up. So now some escape and encapsulation kill switches. So there is add opens. So opening a package basically opens a package up and makes everything in it public. So that's one way of escaping the module system. So if you need to open up something, you can say add opens, open everything up in this module, right? And then there's also this permit illegal access. All code in the unnamed module can access other types regardless of any limitations. So this is the kill switch for getting things to run, that ran fine on Java 8, getting them to run fine on Java 9. Now this is going to be results currently in a warning, and so the permit illegal access, well, that may get you around problems today and get your application actually up and running. In Java 10, they're going to pull it. Okay, so moving on to services. Okay, whoa. Okay, so services, the API was first added in Java 6, and it's rarely used outside of the JDK. They've enhanced it and altered it for Project Jigsaw. So in this case right here, I want to have a messaging service and then have an implementation of it, an email service, a text messaging service, etc., that you can then, dynamically add and look up the services. So in order to do that, I create my message service and my API. So I create my message service interface, right? And I export the interface, and then I requires the model interface, and I export this, export the API, and then I have my implementation of it on the slide right here. So I have my model, and it provides, so this is the actual implementation. I provide this API with this implementation of it. So you can kind of see this is the implementation of the service. So this is the implementation of the service. So I'm saying that this module requires this API, and it is producing, this is the interface of the service, and it is producing this implementation of the service for others to use. And so this is an example of actually using it and then iterating over the list of services. So you can, this is a way of having, because the module system has to be resolved in startup, this is a way of adding in basically services that you can then add to the class path and have it dynamically found out. So moving on quickly to tooling. Early access builds are available. One very handy utility if you're trying to switch between Java 8 and Java 9, and this works on Sigwin on Windows as well, is this JNV-ENV-IO, which you can install via brew. So it allows you to easily switch between Java 8 and Java 9. So when I'm switching between the two of them, sometimes I want just one window running Java 9, and I want my other windows being able to run Java 8 so I can get my work done. This allows you to do it. In terms of the tooling support, IntelliJ has support for it today. NetBeans Developer Preview is out there, and we'll take a look at that. There is a status page, which I have a link to right here, with the different statuses of the different modules with Maven and where they are at right now. One thing to note, that if you're using the Maven Shade plugin, which generates an Uber jar, that would actually cause you quite a bit of problems with the modules, because it collapses everything into a single jar file. Which obviously is not going to work very well with the Jigsaw and the plugin system. NetBeans in Java 9, the developer previews out there, they've added in a specific project type for Java modular project, and creates a modular project which you can add modules to. The one caveat with NetBeans on Java 9 is that it'll flag that these imports, there's no module import for them yet, but it doesn't actually auto-import the module for you yet, which IntelliJ will do that for you. IntelliJ added support, as I mentioned, in 2017-1. You start with an empty project, and then you add modules for each of the Jigsaw modules. That's how I've been actually using it. I'll actually skip the demo because I'm running out of time. Move on to best practices. So for Java 9, analyze your dependencies using JDepends, fix code immediately that are using internal APIs. Integrate the Maven JDepends plugin. Look for your code. What are you doing for reflection? Are you setting accessible to true? That would be something that you should search through your code base to check out if you have problems. Refactor and remove. If you're planning on modularizing and using Jigsaw to modularize your application, look for packages where you have com foo utilities throughout your source code base. If using internal JDK APIs, you can fix or use these for the flags to get around problems. IntelliJ's got this nice thing. So remember how I said they don't allow cycles? So you can use a DSM. This is from IntelliJ to analyze and look for cycles within your code base. This will actually go through and analyze your source code and produce this nice little graphic, which you can then look at to find dependencies between your source code. So if you haven't tried playing around with DSM, it can kind of provide very interesting insight into your application. So for Java EE, support for Jigsaw is unknown. I believe Spring Boot supports it. There's been some discussion of that. Desktop app impact, I think, from my perspective, I think that a large impact will definitely be felt on on older Swing applications that are using hacks to get around limitations in Swing. So I think that that's going to be a major issue. So as I like to put down at the bottom, the technical debt bill is now due. So if you've been putting off and like, oops, you've been using some APIs to get around problems because you didn't want to actually anyway, you didn't have time to engineer it or build up a package for replacing it, the bill is due now. So you've had umpteen years. So some best practices, don't depend upon Java SE. So don't put that in your requires. Avoid using qualified exports. Don't remove exports from a module in future releases. So don't change your change what packages you're exposing, because it'll break code that's already out there. Keep module infos.clean. The IDE so far not flagging situations like this, where you include controls and you also include bases or duplicate. Some resources. There are 2 books that are out right now on it. I don't know if they'll have to change the books depending upon what happens between now and September. A bunch of links. There's the Oracle Talks, where they have all of their recorded slides and presentations. So that's a pretty good. There's some presentations out there that go more into depth as to how it was implemented. The Jigsaw vote, explanation for why people voted no, and then I'll have the slides up later. And if there's any questions, I think I'm out of time, so stop up or catch me afterwards. Thank you.